so we have a filter over a table, which is a bad idea. So in DAX, you should filter columns, not tables. And when it comes to filtering a table, you obtain a behavior so that the table reference is evaluated in the current filter context before the calculate applies other filter. And the result of the table with all the columns of the table is applied to the filter context, replacing existing filters. Now, when you think about the behavior of this and you want to replace the table filter with a column filter, you basically remove the filter function with the table reference, and you keep the predicates, possibly having one predicate for each column. Especially when they are in an end condition, it's easy to do. But by doing that, if you just do this, you obtain a different behavior, because at this point, any existing filter over the columns that you're filtering is ignored because of the semantic of the filters, which is different. When you apply a filter over a column, the existing filter is replaced unless you write keep filters. Now, because when you wrote a filter using a table reference, you were absorbing the existing filter context. And as a consequence, any existing filter was applied before applying your additional filter. So the two filters were merged together. If you just remove the filter table and you keep the predicate, the condition, you will obtain a different behavior in certain reports. In order to avoid that, we use keep filters. Now, keep filters by itself doesn't improve the performance. Keep filters, though, is required, because if we want to transform a table filter to a column filter, which improves the performance, but the existing table filter had a different semantic, which correspond to the semantic we obtain by using keep filters. And so this is the reason why we use keep filters, not because of the performance of keep filters, but because the keep filters were required to keep the existing behavior of the measure.
Okay, thank you. So let's go to the next question. I will find it here. Okay, activated. Okay, so the next question is, do the waiting times other in the performance analyzer, that's the other item in the performance analyzer, relate to all computer hardware? What kind of computer do you recommend for using Power BI?
So the other waiting times that you have when you have multiple too many visuals in your report is affected by the performance of the other visuals. So in an indirect way, if I have a faster machine, every other visual will be faster, and so my waiting time should be shorter. But as usual, it depends, because we are talking about Power BI Desktop. When you are using Power BI Service or Power BI Server, then the waiting time also is caused by the communication between the client and the server. And having a faster machine does not affect in a direct way the network performance and the latency you have in the communication. So in general, yes, if you have a faster machine, you should see a shorter amount of time, but it's not a solution by itself. The solution is always to reduce the number of visuals. The following question is, what is the best hardware for Power BI? And so there are two elements to consider. One is the RAM that you have, and the other is the CPU speed that you have. Ideally, I will not use a machine that has less than 8 GB of RAM, possibly 16 or more, depending on your on the size of your model. But even though you have a small model, I'm sure that if you have 8 GB of RAM, it's pretty much the minimum to run Power BI Desktop in a smooth way. I would suggest 16 or more those days. About the CPU, it's very important here having a high clock rate speed. So let's say that if you have a machine that has a clock speed about 2 GHz, we can consider this in a very not very performant area. We try to find something that goes above 3 gigahertz, possibly 4, right? So especially for a desktop or for a notebook, having that is more performant will be better. Unfortunately, when you have faster performance in a notebook, you have a lower duration of the battery because you are increasing the consumption. So the ideal situation is having one of those modern CPU that can have a turbo speed very high, but in regular condition, try to lower the speed because there is no demand for performance, and so they consume less. So this way, you find a trade-off between both. Usually, modern CPUs are good, but if you, especially when you go at the low end, so if you buy a computer that has a low price, sometimes a small difference of price in those computers could make a huge difference in performance. So especially, so if you spend like $2,000 or more, usually you are not going in trouble for a notebook. But if you are trying to save money and get a, you know, the minimal requirement, then take a look at the CPU speed and don't just get the cheapest one just because it could be just because they have an older generation and a low speed clock rate that will affect the performance a lot. So RAM and CPU are the two parameters you have to check.
Perfect. Okay, so the next question, if I select that one, this one. Okay. Do you recommend using query folding, SQL statement, or Power Query? Which one has better performance and which one do you recommend?
So Power Query is not my area of specialization, but I know enough about Power Query to answer to this question. And query folding is a strategy that Power Query uses to offload part of the calculation to the data source. So if the data source is a relational database, then many transformations could be translated into a SQL statement. And usually, this results in better performance, usually. So there are always exceptions to any condition, but usually this works. So the answer is yes, it's a good idea. But as usual, it depends. For example, imagine you have a complex transformation that involves creating a lot of subqueries. So at that point, it could be faster having a local copy of the table imported and working on it. It's hard to have a full control over that, to be honest. But sometimes in Power Query transformation I created, I wanted to stop the query folding because it was creating a too complex query for the data source. And it was better to, for example, there is a function called table buffer, which stops the query folding. And from that moment, you have the data in memory and you work locally. When and how to do that? It depends. You have to know Power Query and SQL well enough to realize the differences of this. And it's hard to establish exactly what is the point where you want to do that. So it depends on many factors. Another thing I usually do, the table buffer is also a way to provide a point where you specify the data type of the column so that you don't have to wait too much in the editor just because the engine has to retrieve the data just to figure out whether a column is an integer or string. And so sometimes you can provide this information. I don't think the function is table buffer is another one, but you can provide the actual data type of each column. And so maybe table view. And the engine stops not query folding, but the operation of checking what is the data type. I think that Chris Webb has many blog posts about this topic. So query folding, Power Query, optimizing the development environment, and the execution of the Power Query transformation. I suggest that you take a look into the Chris Webb blog post. There is a lot of content there about these topics. I learned from there. So.
Thank you very much. Not this one. I shared the wrong screen. Sorry, guys. Okay, so the next question is, and that's related, I think, to the previous question. To cleaning the data, we have to use different steps in a table in Power Query environment. A large number of the steps will reduce the speed of Power Query processing. Is there another suitable solution? Yeah.
So again, usually the problem, again, these topics are covered very well in the blog from Chris Webb. He wrote long posts also 2, 3, 4 years ago about this. And one of the problems is that, especially when you are in the development environment, in the Power Query editor, it's going to be very slow for one reason. Every step executes the previous steps to figure out what is the data type of each column. And so if you have 10 steps, so the first step, execute what you need. The second step, execute the first step again. And this increases every time. But this doesn't happen when you refresh the model and you just import the data in general. But with one exception, which is at the beginning, Power Query has to figure out the data type of each column to know which data type will be the result to store in Power BI. And when you see that you wait a lot of time before you see the first row coming, it's just because basically what is happening is that the entire process is executed once to figure out, okay, what is the data type of the column? And then after that, it repeats again. And at that point, only at that point, you see the rows coming. If this is your experience, again, the solution, if you want to keep, okay, one solution could be reducing the number of steps, but reducing the number of steps could be not a good solution because you actually makes, you reduce the operation that you can do. Another solution that is very effective is to define manually how to combine, how to define the data type of each column that you want to attain, because this removes that first step of the transformation. Again, I don't remember exactly the link, but if you look for Chris Webb Power Query data type or view or something like that, I can search, but yeah, there is a link. Well, let me see if I can find it, but there is a link about that. There is a blog post. Power Query. I can provide a link on this one. Check the query. Not sure. No, this is not. But because there are so many, and it's maybe we can if you send me an email later, I will try to find the links to these posts that are very important, and we will share with the community.
Sure. Okay. So the next question is, how can both directional relationship be avoided? How does that type of relationship affect the performance?
So the first reason why you should avoid the bidirectional relationships is because they could create ambiguity in your model that ultimately could create wrong numbers for your report. This is a biggest problem than the performance one, right? Because if you realize that, oh, in my model, especially when you start creating models that are more complex, that have more than one fact table, you end up very easily in situations where you could have a complete random number in a few reports. I think we have an article and a video about that where we explain the problem from the correctness of the calculation. And this is by far the more important reason why you should avoid a bidirectional filter in the model, which doesn't mean that you cannot use bidirectional filters. It means that you can and you should enable bidirectional filters for specific measures where you need that behavior, which usually doesn't mean all the measures, only a few measures that actually can benefit from the bidirectional filter because of the particular type of calculation that you have to do. Now, the bidirectional filter, though, has a higher cost in the processing because only a regular one-to-many relationship creates an actual index in the engine that can be used by the storage engine to solve the query. Whenever you create a bidirectional filter and you use the propagation many-to-one, also when you create a many-to-many cardinality relationship, no matter what is the filter direction, in those cases, you don't have, you might not have an index. And in any case, the cost for transferring the relationship is higher, and the measure that you have on the one side of the relationship is no longer additive, which has another consequence. Think about a sum, right? You create a report and you have the sum of the quantity. If you have a one-to-many relationship and you say, okay, I have the product color and here I see the sum by product color. A product can have only one color. So the grand total is actually the sum of the numbers that you see. So we call this measure an additive measure. The moment you work on a relationship that is bidirectional, by definition, the same product can have a multiple colors or better. So you no longer have, imagine that you have a table that has, for example, the sports played by customers. So you have sports, you have customers, you have sales. So the table sports has a sport and customer key, and the same customer can have multiple sports. Now, for every sport can have the sum of many customers, but the same customer can be included in several sports. At this point, every cell is a separate query. You can no longer, the engine, not you, but the engine can no longer make the assumption, oh, look, I need a join, I need a group by in SQL. Think about SQL. I can do a group by in SQL with a single query, get the result. No, every cell is a different query. Every cell might have to compute the same customers again and again and again. I could have a customer that plays all the sports, so his value must be included in all the rows, and the total is another calculation. So instead of doing a single query, you have to do a query for each cell, and this is more expensive. It's not a problem of the engine. It's a problem of the calculation that you're requesting. The calculation that you're requesting is requesting an additional number, a bigger number of calculations, and this costs more. Then the engine can do what it can. But again, do you really need that? Because I have seen a lot of times where this was not needed, or this was not the intended behavior, and the bidirectional filter was there for some other reason. And the side effect is that the engine, because of the bidirectional filter, even though the data do not have this requirement, you were paying the price of a different query plan that assumes that the calculation is no longer additive, even though you actually don't need it. And so this is the reason. So this is the reason. So ambiguity, and from a performance point of view, your request is way more expensive, and for this reason, the performance is worse. But again, it's not the engine that is slow. It's a request that is an order of magnitude or two more complex, and this reflects in slowest query.
Okay, thank you, Marco. Let me go for the next question. And I believe you already answered that in the video. So the question is, the SE is 0 on Dax Studio. Is that an error, or do I need to change any setting?
Well, this is usually what happens if you run the same query multiple times. The storage engine has a cache, and the second query that you, so for example, you have a query, you run the query once, the second time the query should provide 0 for the storage engine, for the storage engine cost. And you should see at this point that there is a query in the storage engine, but the time is 0. When this happens, you also see that the query is counted as a cache. So in the lower pane, you see the number of queries and the queries that have been requested from the cache. When you see that all the queries have been requested from the cache, guess what? You have you're just querying the cache. For this reason, when we do performance analysis, so the cache is good in general, But when we want to analyze the performance of a single query, we always clear the cache and then run the query. You can do this manually with two operations: clear cache, wait for 2 seconds, and then run the query. Or you change the behavior of the run button. There is a small arrow that you can click, and you say, okay, clear cache and run, so that each time you click run, there is a clear cache, and immediately after that, a run. So in a single click, you clear the cache and run the query. And so you should no longer see queries that have been returned by the cache, unless it happens within the same query, which is absolutely normal. But you should see a few queries that are consuming storage engine cache. The other reason could be that the model is so small that it is actually 0 seconds. But I don't know if this is the case for your model.
Okay. I think that's it. That's another question, and I didn't remove that because it's related to the topic and not related to topic. So, and that's in what scenario should we use direct query import mode when we want to connect to the other sources? So I know that maybe that's related to the performance of the report, so I keep it here to ask it from you.
So this topic sometimes is a sort of ideological question that I prefer not to discuss. I don't have any. I try to not have any bias about that. What I can tell you is that you want the best experience with Power BI, you import data, right? So that's and not only about the performance, okay, about the performance, about the feature, about the flexibility in the design, about everything. So you import the data, you have the best user experience. Full stop. So the real question is, why should you use direct query? So when direct query is required, and he enter into an area where people have different points of view. My point of view is because you hardly get the data, you should hardly get the data from the database that actually has I don't know, your accounting system, your ERP. Having the problem that many say, oh, I want real-time data. One of the reasons why people say, oh, I want to use direct queries because they want real-time data. Now, usually you don't want this. And I explain you why. Because if you do this and you connect to a relational database where you have all the transactions of your system coming in real time, the structure and the shape of this database is not ideal for the analytics that we want to do. We should have a star schema. Oh, we have to design a star schema, which is true, but usually this requires transformations. How do you want to do these transformations? If you want to do these transformations in Power Query, for example, the requirement for direct query to work is that all the transformations should satisfy the query folding, which means that the level of the transformation that you can apply is limited, or as an alternative, the result of these queries is very, very slow. So my point of view is, if you have a star schema, the star schema is updated every hour, 2 hours, day, I don't know. So you just can import the data immediately after that. If you don't have a star schema, you have a bigger problem. You probably your ability to analyze that model also in real time is very limited and could create a lot of work, a lot of slowness in your database. So but you say, but I have a small amount of data, so import it. What's the problem? If the database is small enough that you can not worry about the performance that you will have on SQL or on the data source, import it. You are actually saying, I don't have a reason to not import it. Because if it is so small, you will not have so many changes, right? Because if you have many changes, it should be large. That's my. Now, if you say, but the model is so large, I cannot import it. Okay, but at this point, you are in the opposite side, which is, if you have such a huge volume of data, you will not have the user experience you expect from Power BI. When you click a slicer and you immediately see the result, you click a slicer, then you get a coffee. And then when you come back, maybe that you see the result, or you wait more. So that's the problem that I see. In my experience, and I'm not kidding here, 90% of the times, direct query was used for the wrong reasons, full stop. This is my experience. It could be wrong. It could be that I only receive people that are, creating bad models and then call us. I have no idea, but this is my experience. Most of the times this happens. Now, if you have a small database that changes often and you want to see these updates immediately available in the Power BI report, and you don't worry about the workload that you will push over SQL, because you will no longer have any cache. Every single query that runs in Power BI will send a query to SQL. Okay, so if you have 100 users, this is going to happen. It could kill your SQL server. But if this is your condition, fine, you can use direct query because of the low latency you want between someone changing the data on SQL. I want to see this change reflected in my Power BI report, and possibly I want this latency to be less than 1 minute. If this latency can be 15 minutes or more, let's say 30 minutes or more, come on, you can import the data. You can import the data because if the data is small enough, the refresh doesn't take much time. If the data is larger, you will certainly have other problems using direct query, and performance is the last of your concern because you would have a scalability and a reliability issue in terms of service SLA on SQL Server that if you have many users, you will see. So that's my point.
Thank you, Marco. Okay, so the next question. Morteza asks, now in most of our projects, we connect the Power BI directly to the data warehouse, DW, and do not use SSAS. Is this technically wrong?
No, I mean, Power BI has its own analysis services engine. Power BI is analysis services with a report on top. So when you connect Power BI to analysis services, you are not using part of the features of Power BI just because you're using the same features on another server. When you use Power BI and you import data, you are importing data in analysis services. The engine of Power BI is analysis services. So it's actually the same engine. When there is an update in this engine, you will see an update in Power BI, in Azure Analysis Services, and 1, 2, 3 years later in SQL Server Analysis Services on premises. So you actually in Power BI, you have the latest feature of the engine, just like Power BI Service. And so in Power BI Desktop, you have the latest features, just like Power BI Service and Azure Analysis Services.
Perfect, thank you. So the next question is, can we use tools or tricks to show us times of fetching data, processing and visualization rendering in Power BI like execution plans in SQL Server?
So the tool that you have today to do this is DAX Studio. You say, but I don't see the query plan that I see in SQL Server with a graphical indication and so on. True, but it is not possible. And not because you don't, I mean, technically, it could be possible to create a more graphical visualization. It's not impossible, but it could be useless because you will see something that is not possible to represent in a small diagram. The query plan, if you try to analyze the query plan actually already has the information that you're asking. It just displayed as a tree instead of being displayed as a flow with chart. But that tree reflects the execution plan, and it is very different from SQL. It is very different from SQL. So it's a complex problem. So the first issue is that it could be technically possible to create a graphical representation. It could be just useless. So why investing a lot of work for something that would be unusable to most of the people? Now, I would like it. Okay, don't get me wrong. I would like it, but I understand that it could be not the best investment that Microsoft make. As of today, we don't have the information. So on external tool, even though you say, okay, can we do this in Dax Studio? The answer is no, because as of today, the query plan that we obtain out of the engine is limited to 10,000 rows. So if when the query plan is longer and more complex, it is truncated and it is not available in full. Not to mention that the format will not contain a number of information that would be necessary to create a graphical representation. But what I'm trying to explain is, first of all, Microsoft should expose a complete detail of the query plan that today does not expose, especially for the complex queries, because when the query is too complex, it becomes longer than 10,000 rows and you don't have the full picture. Then it should add to this information additional elements to provide a full graphical description, because there are a few details that are missing there. So once this work will be done by Microsoft, an external tool could do that. But I don't think that this will happen soon, at least. I mean, I don't see this as a priority, because again, if you think about the value of what you can obtain, you say, okay, Microsoft does this job, someone else does another job in the community. I have no idea, because also for us, I will make the same choice, because knowing the low value that you could get out of this visualization, why should we spend time investing on that feature rather than another feature that could be more useful? Because time is limited resource for everyone, not just for Microsoft. So I don't think, honestly, I don't think that this is going to happen.
Okay, great. Before we move on to the next question, just want to highlight this to the people. I shared the Pigeonhole link, so you can click on that one and submit your question. I will ask those questions from Marco. Okay, let's move to the next question. The question is, all expect, remove filters, or all selected. When should we use one of these formulas, and which one has a better performance?
Every function that you mentioned does different things. They are not comparable. So they could be equivalent in a few narrow cases, but you're talking about different semantics. And when they are equivalent, also the cost is equivalent. So the choice is not about the performance. The choice is about what is the meaning of what you're doing. In general, I would say that all except is very, very rare to be used. It solves a specific issue that usually you don't have. Okay, in particular, it could be useful to avoid a circular dependency in a calculated column invoking references when the table doesn't have a primary key. As you see, it's a very specific condition. Or when you have a similar problem, or of course, of circular dependency using a calculated table in a relationship that has a calculated table on an end of the relationship. So something like that. And this happens when the context transition has to remove the dependency from a few specific columns. So that is a very, very, very specific situation that most of the people don't have as a problem. All except could be used for the wrong reason. When, for example, you create a measure that says, oh, I want to compute the percentage of the category. So you could write all except product category, or you could write remove filters product values category. Usually the latter is better, because what happens if you have a report where you have the subcategory without the category? The solution with all except will not provide the right solution, whereas the solution with remove filters and value would provide the right solution. This is, for example, this is discussed, I don't remember in which article, or if you search for remove filters all except, For sure, this is covered in our Mastering Dax training, in the definitive guide to Dax book. I don't remember if we have an article about that. All selected does another thing, which is it replaces the filter in the filter context with the filter context that you have for, let's say, outside of the visual for a specific column. So it's different from a remove filter. It could be what you want most of the times, but again, it's different from remove filter. So it depends. But all selected should be compared to remove filters. All except is a very specific thing that has another purpose, and they are different from the semantic. So the performance is a lot of your concerns. The first problem is, what is the right formula for your requirements? That is the first question, and it depends.
Okay, thank you, Marco. And I think this question is related to that previous one, and that's in our Dax expression, when should we use filter with calculate? And when we should we need to use other formulas like keep filter.
Okay, from the description of this question, I have to make a few assumptions, and one of the assumptions is that it is not very clear that calculate always creates a filter, and a filter is always a table. So if you write calculate measure a column greater than 1, what happens is that columns greater than 1 is transformed into a filter function that generates a table, and the result of the table is pushed into the filter context. Full stop. So the fact that you wrote filter or not doesn't really matter, because every write you write a predicate, a condition in calculate, you are creating a filter. Full stop. The filter should be a filter over a column, which is what you get automatically when you write a predicate. If you wrote filter table, 99% of the times you made a mistake. Sorry if I use this wrong word, but you actually made a mistake because you used a way more complex solution to a simple problem. You moved the truck when you could have moved the bike. That's the problem. Because instead of filtering, instead of creating a table in the filter context with just one column and a small number of rows, you created a large fat table with all the columns of the table, all the rows of the table that correspond to the condition that you applied, and this huge table is applied to the filter context, which is way more expensive. What you have seen in the video is that instead of creating this large table, we can create a small table, but at this point, in order to keep the same semantic, we had to use key filters. But key filters simply says, don't overwrite the existing filter, period, full stop. Okay, so this is how Dax works. Now, we have articles where we describe all the single individual aspects, but my suggestion is, if you learn how Dax works, it's very clear. A key filter is just a way to say, I want to obtain this behavior or I want to obtain this other behavior. And one of the examples that we show in our training is that I show two different requirements. In one, you have to use key filter, and the other, you don't have to. And there is no answer. It depends. For this formula, you need it. For this formula, you don't have to use it. Otherwise, you get wrong numbers. Performance don't depend on the key filters or not. They depend on, do you filter columns or tables? Filter columns is good, filtering tables is bad. And this is, you should avoid filtering tables.
Perfect. Okay, so let's move to the next question. And that's, it is not possible to use incremental load in the free version so that we can keep the data unchanged and new data can be added. What is the proposed alternative method of incremental load?
So the problem is the following. This is a licensing issue, right? The free version of Power BI simply always refresh the entire table. So when you refresh the table, you refresh the entire table. Full stop. It is how it works. Now, you don't really have a solution. What you could do is is not an ideal solution, okay? It's just a workaround. If you have, for example, 5 years, and processing every year takes 10 minutes, you spend 50 minutes every day. So instead of processing 50 minutes every day, you could say, okay, I process only 1, 2, 3, 4. I create a table that has the archive, and I have a table with the current data. And when I refresh, instead of refreshing the full data set, I refresh only one table. Now, this is possible in Power BI Desktop. But once you publish the model, you cannot refresh a single table in the free version of Power BI. Okay, it's not possible because you can only refresh the entire model. The only way to refresh a single table is to use an XMLA endpoint, which is a feature provided only in the premium version of Power BI. So not even with the $10 per month. In Power BI Desktop, it works. Or if you publish the report on Power BI Server, it still works because technically Power BI Server uses analysis services. So if you connect to analysis services and you refresh only the table that has the newest data, you obtain the same behavior. This thing can work in Power BI Desktop. So in Power BI Desktop, you can right-click a table and say refresh this table. So if you have 2 tables with the sales, all sales and sales current year, you actually can just refresh the sales of the current year and reduce the time to refresh. Of course, this has an impact because you have to create a measure that sums 2 tables, the sum of table archived and the sum of table current. Of course, there is an impact for that, but otherwise Microsoft will not get money if they give away everything for free.
Okay, yeah. So okay, let's move to the next question. Okay, so the question is, usually using images in different formats reduce the speed of using dashboards. Do you suggest another way to use images in dashboards or reports?
The problem that you have for I assume that the issue that you are describing, if you are using images in the background of the dashboard, you end up having multiple elements in a page. Each one is a different visual. So instead of creating, I don't know, 10 visuals that are completely static, they don't change, right? They are not tied to any measure, to any column. They're just a line, a bitmap, something like that. Instead of that, you could create a single bitmap to use as a background, and then you apply, the other. There are videos and blogs about that. So if the problem is, I use these JPEG bitmap just for, decorating the layout of my report, this could be a solution. If instead you are using these bitmaps in your report because you have a column that displays, for example, a bitmap with the flag of a country instead of displaying the name of the country, well, in that case, the problem is that for every row, you have a URL request retrieving the flag. But in reality, that is not too bad because usually this is relatively optimized. If you have many times the same flag, it is requested only once and then it is reused. So it shouldn't be a big issue. But of course, you are making other requests. It depends on the speed of the network and other details. So depending on the situation, there is a workaround, single background bitmap, or if you are using this in your data with a URL, you can just try to reduce the number of rows visible because if you request too many bitmap, it takes time. But I actually have reports that do this, and they are usually pretty fast. So I don't see the problem in the second case. I see the problem more in the first case.
Okay. So the next question, there are many questions. I will try to ask as much as our time let us cover that. Okay, this question is field parameter or calculation group. Which one do you recommend in terms of?
They're different, but if you can obtain the result that you want by using the field parameter, use that, because calculation group like measure involves an additional calculation in the engine. You have more flexibility in the calculation group, but it has a cost. So if you can obtain the result that you want performance-wise, the field parameter is simpler. Oh, sorry, the new field, yeah, the field parameter that has been released now. Okay, if we're talking about creating your parameter and using your own measure with a switch statement, then it depends. But if we're talking about the latest feature in Power BI released in May, of course, that feature is faster.
Yeah. Okay. Thank you. Okay, so the next one is to use paginated report or mobile dashboard and other features in the report server, data sets usually have to be created from the main database. Does the development of the data sets slow down the server?
I'm trying to understand the question because the question is related to using report server for paginated reports and mobile dashboard. Don't understand the question because I don't understand why the development of the data set slow down. I mean, from how I can interpret the session is simply no, but I'm not 100% confident I understood the question. The way I understood the question, no, the development of the data set doesn't slow down the server. The development is totally unrelated to the performance of the server, but maybe I didn't understand the question.
Okay, I think that's the last question related to this topic, but there are many other questions.
That's right. If there is something interesting that I can reply, I'm very happy to do that.
So this one is the general one, and I'm pretty sure you are the best person in the world to answer this question.
I don't know
if you let us.
So what we suggest is to start with the Introducing Dax free video course we have on our website because it has been designed to be introductive. Then we have a Mastering Dax that you can use, which is more complete, and that is what we sell. But the Mastering Dax, the Introducing Dax is completely free. However, because it is not only about the video training and it is about other things, I'm copying a link to the chat window, which is how to learn Dax that we have on our website, which has a different path depending on your background. So if you come from Excel, you're a BI developer, or you're a Power BI developer, we provide different paths to improve your learning. And one of the things that you have to keep in mind, don't just limit your knowledge to DAX, try to also study the data modeling. We also have an introduction to data modeling course that is free because if you have a good data model, you actually don't have to write complicated DAX. And so you have to follow both. So if you want to make your life easier, create a good data model and learn DAX, but you don't need too much DAX if the data model is good and you don't have a complex requirements. So probably with a balance of the two, you don't have to go too deep in DAX. And of course, if you like DAX and you want to know more and you want to do also face more advanced challenges, we have a lot of content about that.
Great. Okay, so the next one is to create a simple computational column, such as add 2 columns or multiply 2 columns or do division and etc. Is it recommended to use Power Query or DAX?
So the question is, why do you have to do that at the column level and not at the measure level? Because if you can do this at the measure level, you will save memory. You probably obtain the same performance, and so it could be better to do this in DAX, but in a measure, not in a column. If you have to create a calculation so that you need a column in the table that can be computed using other columns of the same table, usually it is better to do this in Power Query rather than in DAX, because the result of your computation will be better compressed in memory. And especially for a large table, this is particularly important because, for example, if you implement the incremental refresh on a table, The calculation that you implement in Power Query is executed only for the new data. The calculation that you create in a calculate column in DAX is always evaluated for the entire table, even though you refresh only a small partition, a small incremental refresh. So if you need a calculate column, Power Query is better. The calculate column is way better than Power Query only when you have to consider data in other rows of your table or other tables. At that point, a calculate column could be much more performant than the same operation did in Power Query. But my question is, if you have two columns and you want to sum the two columns, why you don't do that in the measure? It will be much faster. You will save memory. Why?
Okay, that's great. So if I want to rephrase that question and just put Power Query aside, between calculated column or measure, which one do you think is better in terms of the performance?
Exactly. And we have. I'm just getting the link because I think that there is the complete answer to this question is relatively long, and we have an article and a video about that. And let me copy the link in the chat window.
Recorded that video.
Yes, correct.
Yeah, I watched
Alberto recorded the video,
times.
and we wrote the article together. But the idea is that if you have to create, if you think that you need a calculate column to produce a number that you display in a measure, you probably don't need a calculate column. If you need a calculate column when you need something that you use to group by or to filter data. Okay, you need a column like, for example, price range, and you group it by price range, or you filter by price range. The filter is already something we might discuss, but for the group by in the visualization, you probably want you need the calculate column, or at least a column. There are cases where the calculate column could offload part of the calculation of the measure, but we are entering into the optimization area. And optimization means you optimize if and when you need it, and you have to be able to prove that your optimization provides an advantage. You have to measure it, and you have to demonstrate that the calculate column provides faster performance than the measure without the calculate column, assuming that you wrote the code the best that you can. And usually you cannot. Usually, to give you an example, there is a 30% difference in performance between sum of a column that multiplies two numbers in two other columns and the sum of the result of the multiplication of the two numbers in the two columns in a table when you have 10 billion rows. Okay, when you have 10 billion rows, you can observe a 30% difference. The cost for the 30% difference is a column that costs many gigabytes. So once you see the performance advantage, you may think, yes, okay, but 30% for consuming this amount of gigabytes, you know what? I can live without that advantage. But when you reduce the work, when you reduce the amount of RAM involved, for a strange effect, you could see the opposite. You could see that the column, the sum of the calculated column is actually slower than the sum of the multiplication made dynamically, because you have to consider that you might have to read a lower amount of RAM, and the RAM could be in the cache of the CPU. And so overall, you're actually spending more time if you had to read a larger amount of RAM that cannot be stored in the cache of the CPU. So when we talk about 100 million rows, I will not assume that my calculation will be faster with the calculate column, because usually I could be very wrong. So it's an optimization. When do you optimize? When it's slow. Think about SQL Server. Do you create indexes just because you want indexable? Every index has a cost. Every calculated column has a cost. You slow down the refresh, you increase the memory of the model. So you are paying a price for something that it could be useless. So you really want to spend your resources, CPU and RAM, for something that is useless? I would not, because it's also your time for creating a calculate column. And so I would say there are cases. I'm not saying that the calculate columns are not useful for the performance. We use that for the performance sometimes, but it's very unlikely. And if the calculate column is actually a column that computes the multiplication of two columns, for example, again, a calculate column is a bad idea. It's better to do this in Power Query and then import the column and so on. So it's really, calculate column and measure should be used for two different things. And calculate column is hardly an optimization unless you do a few particular cases. There are cases, but not many.
Okay, thank you very much, Marco. So there are, I think, few questions, 3 or 4 questions left. So
if there's something about DAX, we can try. If it is not too long.
Okay, this one is related to the topic. So what's best practice in the perspective of performance when using row level security and have 2 or 3 roles?
So for security, this is a long discussion. I'm posting a link to an article. The article has been written for analysis services, but actually the technology is the same, and it can be used also for Power BI. The article is very up to date also for Power BI. So it's the very same discussion. And the problem is the performance issue is the following: when you enable the security, you are technically adding to every storage engine query a where condition, which is where, and you satisfy the condition. Now, depending on the model and depending on the formula, this could have a high cost. And there is an initial cost when the user logs in, because the security perimeter has to be evaluated. This means that the first query could be slow, but then the following one could be relatively fast. But there are conditions where the presence of this additional filter has a huge impact on every calculation that you have in the query plan. And guess what? This happens, especially when you have bi-directional filters, many-to-many cardinality relationship, and so on. Right? So when we said, oh, by the way, whenever you have this kind of stuff and you enable also row security, you have something that increases the cost, and then you add something that adds an additional cost, and you combine them together. It's not just the sum, it's the product, so it can explode. So how to optimize it? It depends. The article I posted provides useful information to evaluate different strategies for optimizing the approach for the row level security. It's not something we can, it depends. It really depends.
Great. So Marco, it's now 1 hour and 10 minutes since we started. Let me know when we need to wrap it up.
No, don't worry. I have other 5-10 minutes. Don't worry.
Okay. So let me just ask this one, and that's about the visualization. The question is, the users usually have trouble choosing the right visuals in their own design dashboard. What solution do you suggest to choose the right solution visuals before designing the dashboard?
I'm not an expert in this area. I can show you. We have, even though it has not been updated for a while, but let me just if I find the link. If I find the link, yeah, this one. So that's a little bit, has a few years, but what you can get from this, so this page contains a PDF you can download, which is a table that groups the visuals by the kind of behavior you have to obtain. So for example, you could have visuals that are useful for the comparison, for looking at the change over time, for ranking, and so on. You would see more or less 10 groups, and we describe these groups. Actually, the reason why we have this PDF is because we have a training a relatively short training. It's called Power BI Dashboard Design. Sorry, Dashboard Design in Power BI is the name of the training. And this training has been developed by Daniele Perilli, who is our designer in SQLBI, and Alberto and I simply provided the voice and shown the content, but actually the content has been produced by Daniele. And in that video training, we explain each single group of these visual, what is the role. So of course, then you have to choose the visual that actually you like within the group that makes sense for the kind of metric that you want to display. So as usual, the answer is it depends. Beside this PDF, if you want to look into the data visualization space, there are many books and probably videos and trainings also from other that are not specific for Power BI. So these concepts are not specific for Power BI. These are data visualization concepts that are pretty much universal. Once they are applied to Power BI, of course, you have to figure out what is the Power BI visual that has. But at that point, most of the majority of the problem. Okay, here I need a line chart, or here I need a bar chart. Why you choose between one and the other? This should not be an issue, because this should be clear. Okay, it depends on the metric that you want to display. It depends on the axis that you want to display. And now, which of the many line chart I want to use, that's another problem, right? It's more graphic design. But in terms of the mistake you don't have to make is choosing the wrong type of visual. Once you know which type of visual you need, then it's a question of finding a better balance between the visualization and so on.
Okay. There are a few other questions, and I'm pretty sure those people can find the answer of those questions if they watch the record video, which recorded by Marco, and I shared that in the group, the Persian Power BI user group in the LinkedIn and Telegram. You can find that, but there is just only one question, which is a little bit and then if I want to short that question, that line question short is it possible to add a password to PBIX file like Excel like Excel or not?
Now, if you have, no. So the simple answer is no. And I will add one other thing. Do not store in the model, in your DAX formula, sensitive information. So if you think that you want to protect your model because your formula has to be protected, be careful, because a malicious user could find it anyway. Also when you publish on the server. Now, Microsoft is hardening this, by the way, so they are putting more restriction to avoid this to happen. But the only secure way is you publish data with row-level security, and it is guaranteed that the user that accesses the data will not see the data that he cannot see, period. But we're talking about the data. Metadata, it's a different story. And so if you have a Power BI desktop file, what do you want to protect? The data or the metadata? Because in both cases, you're in trouble. The only thing that you could try to protect is, I want to move this file from this place to another place, and if someone in the middle finds this file, I don't want him to open it. Okay, if this is your problem, simply zip the file with a password, encrypt the file with a password. But this is not a problem of is the same thing that you will do with any document. Imagine you have a text file and want to send this text file, encrypt it. It's the same thing. But you cannot make any assumption. Once you have something local, a user can get everything: the data, the metadata, the formula, everything, no matter which kind of security you apply to. Because at the end, what you have is data that can be analyzed, and I will not rely too much on just a password. Even though they provide a password and they just don't trust it, because if you have a serious concern about security, just don't do that. Don't expose this. If you have the local file, you can see everything, period.
Okay, thank you very much, Marco.
You're welcome.
Learned a lot from you, and thank you for accepting again my invitation, and appreciate your time.
It was a pleasure.
I know how busy you are,